Okay. The goal right now is to finish 3 questions. We're dealing with 2015 BC Frqs. Okay, so we have a particle. It's moving along the curve in the xy plane. We're given the velocity vector. We're also given an initial condition that at t is equal to 1, we have the point 3 comma 5. Okay, the first one, we have to find the position at a specific time. And that means you need to know how to calculate the value. Now, this formula comes up a lot. I answer this question a lot. Here's the generic formula. F of x equals the integral from a to x of f prime of t dt plus f of a. I am sharing it. Let me put it real quick on the... Just in case, so you guys are joining your Chromebook, just lower the volume because I have the mic on. So this formula, again, every time you want to evaluate the function, like here, find the position at 2, and you're given a derivative, just always go with this equation. For our purposes, though, we want to find the position of the x coordinate. So instead of saying f, I'm going to say x of 2, because we're looking for the position 2. X of 2 is going to be the integral from something to 2 of the derivative of x, only x, plus f of a. So what's a and f of a? 3 is both a and f of a?
No, a is 1.
A is 1, because they told us that at time t is equal to 1, f of a is 3. That's the position of the x coordinate, and we're only concerned about the x coordinate. That's the setup. With this, you would have already earned 2 points. The third point comes from getting the answer. Type it up in the calculator. The answer here is going to be 2.557. Sit right here. Bring her over. Okay. B. We want to find the slope, dy dx. Oh, yeah.
When you put it into the calculator, the function that you just saw,
Yes.
what do you put in for x of t? You put in cosine t squared.
You mean for x prime of t? Yeah, you put cosine t squared because that's your x prime. I'll label it up here. This one is x prime, and this one is y prime. So yes, you put x prime. Now they could also tell us to find the position of the y part of the y coordinate, and you use the other one. They can ask us for the position of both. So then you got to do 2. You got to do 2 and present it as a vector. Okay, B, the slope. We want to find the slope of the curve, which means we want to find dy dx. But this is not your regular dy dx from last year. This is your parametric dy dx, which means you're doing dy dt divided by dx dt. Your dy dx is composed of 2 different equations. Do we have dy dt and dx dt? We do. Which means dy dx is going to be, and I'm going to set it up for you guys, e to the 0.5t divided by cosine of t squared. And they say we want to find the slope at 2. Do it with the calculator because you're going to have to plug in 2. I'm going to write a little line right here. This is communicating to you guys that I'm supposed to plug in 2. You plug it in with the calculator. You're not doing math 8 because you already have a derivative. Right? You're just plugging in what you see on my paper with a 2. And the answer is... Oh, wait. Sorry. There is a point. That's what happens when I don't read the whole equation. There is a point on the curve where the slope is 2. Yeah, sorry. Set it equal to 2. They already told me what dy dx is. It's equal to 2. So in this case, we're looking for the t that makes this true. You graph it, you find the points of intersection. Do you feel comfortable doing that? Okay.
You just grab 2 and the function, right?
Mhm.
Where-
Yeah, I don't know what it's gonna look like. Maybe something like this, and then y equals 2 is like that, and you just find where they intersect. And the answer is 0.84. This was another 2 points. One for just basically showing that you know what a derivative looks like, dy dt. I mean, I'm sure they'll take this as well if you skip the first line, but you need to learn, the basic formulas because the setup is worth some points. Find the time at which the speed is 3. So we need to know our speed formula. Yeah, if you don't have that, make sure you make flashcards. Speed for a function that is dealing with parametric is the square root of x prime of t squared plus y prime of t squared. That's it. That's speed. Now plug it in the calculator carefully. I'll show you what it should look like. It should look like this: cosine parentheses of t squared, and in another set of parentheses, make sure you're squaring the whole thing. So make sure you use parentheses. Then you're gonna have e to the 0.5 t, close it all off in parentheses and square it. They're telling me what the speed is. So do I plug in 3? That would be 1 point for setting them equal to each other. And then, of course, just like in the last one, you graph them, you find the point of intersection, and you get 2.196. You read it wrong? You plugged in 3, or
Yeah, that's what
it happens? I was about to do the same thing with B. So read it carefully. Read it multiple times. Okay, part D. Find the total distance traveled. If you know your formula, you will get 1 point because the formula would give you the setup. It's basically just integrating speed. Total distance traveled is integrating speed. And we just wrote the formula for speed. They want us to find the total distance traveled from 0 to 1. And again, you're just putting the equations here. But I'm just going to write x prime squared plus y prime squared dt. Just plug it in carefully in your calculator.
will it still give you the point if you write x prime of t and y prime of t?
Like the way I have it?
Yeah, like
Mhm.
instead of writing the actual.
Yep. Okay. Okay. I'm gonna mix it up and I'm gonna jump over to another group. Keep working. Feel free to keep looking.
Yeah.
I don't know if you can still hear me. For number 5. Join me with number 5. Perfect. No, I don't have extras. Open the PDF file or do it on a piece of binder paper. Okay. So all of you should be on 5 with me. Consider the function f of x. K is a non-zero constant. And we're also given the derivative. So you don't have to derive it. For part A, they're telling us that k is equal to 3. And they already plugged it in for us. Okay, write an equation for the line tangent to the graph at the point whose x coordinate is 4. Okay, tangent lines. What do we need for a tangent line? We need the point and we need a slope. Exactly. See, because we already have the x coordinate. So now we just gotta get the y coordinate. So if x is equal, oh no, they said 4. See, that's why I need to have, I don't want to be scrolling up and down. They already told us what f of x is. It's 1 over x squared minus 3x. Finish it, get the point. This is 1 over 16 minus 12, which is 1 over 4. So my point is this. Now I need the slope. Well, we already got the derivative. We just have to plug in k. My derivative, f of x, f prime of x, when k is equal to 3, it's 3 minus 2x divided by x squared minus 3x squared. Plug in 4. So here I'm just going to plug it in, right? 2 times 4 is 8. 4 squared is 16. 3 times 4 is 12. Keep working. Negative 5 divided by 4 squared. So that's your slope. You get a point for getting the correct slope. You get a point for writing the correct tangent line. Your tangent line is y equals m x minus x1 plus y1. If you put the y1 on the other side, you're fine as well. But it would be y minus y1 instead. But this is how they have it in the rubric. Okay. B. Let me know if you have questions, eh? So now they're switching up k on us. Now k is 4. And f of x is already built for us. Okay. Does it have a minimum, a maximum, or neither? What are the general steps when you look for critical points? Set it equal to 0. After you set the derivative equal to 0, you solve it, you find the critical points, and then from there you test it. So let's do that. Find your derivative, f prime of x, when k is equal to 4, would be 4 minus 2x divided by x squared minus 4x. That's your derivative. You set it equal to 0. Now, technically, you could solve for x, but we're not looking for max or mins. We're just checking if there is a max or min at a particular point. So you can just plug in 2 to see if it does give you 0. 4 minus 2 times 2 divided by 2 squared minus 4 times 2. 4 minus 4 divided by negative 4 squared. The denominator doesn't matter. What matters is the numerator. So first of all, it does qualify as a critical point. You have to first show that. That was the first point. Consider f prime of 2. So yes, x equals 2 is a critical point. Now you can test it. Because if it wasn't a critical point, then automatically it would already be neither. Now you can test it with the number line. When x is 2, what's going on with the derivative? Let me write the derivative right here so we have it in front of us. The derivative would be 4 minus 2x divided by x squared minus 4x. All right, let's plug in something. I don't know, plug in. And then what would that be? Positive over positive? Okay, you don't have to plug in negative infinity. You can plug in, I don't know, 0. Right? You can plug in 1. But yeah, it would be positive over positive. Plug in 3. Negative on top. And positive in the bottom. So it's just negative. So positive and negative, which means we have a maximum. So just say it. F has a max at x equals 2 because f prime changes from positive to negative. Okay, that was another 2 points. Again, one for considering that f prime of 2 is equal to 0, and then the other point for the answer. Okay. 3, or C, find the value of k for which f has a critical point at -5. Oh, I think I'm writing too big. Yeah, let me see if I can shrink this. Yeah, buddy. I'm gonna need some space for part of D. Okay. So again, critical points, right? That happens when the derivative is equal to 0. F prime of -5, just plug in your -5 into your x's. 2 times -5 divided by -5 squared minus k times -5 squared. That's what the derivative would be. We want it to be 0. K plus 10, 25 plus 5k squared. What would you do? If the top is 0, then the whole thing will be 0. That happens at -10. That was the point. That's the only point they were assigning for this problem. Technically, if you also did the bottom, that would mean the derivative is undefined, which also qualifies as a critical point. But it wasn't included in the answers. So showing it shouldn't disqualify you. But this was the point. Okay. Part of D. When k is 6, f of x is given. Find the partial fraction decomposition. Find the integral of f of x dx. Okay. Because they want us to find the integral of f of x dx, and we already have f of x, we have 1 over x squared minus 6x dx. Now, this is not your substitution.
This is a partial fraction.
This is partial fractions. Exactly. Which means you have to factor out the denominator. Then, what we talked about in class is that you can break apart this. So we're going to be looking for a constant where a is divided by x, one of the factors, plus b divided by the other factor. And then you keep doing that for however many factors you have. But we only have 2. So we got to solve for a and b. Take this guy and make it equal to this guy without the integrals, right? So 1 over x times x minus 6 equals a over x plus b over x minus 6. Exactly. We want to get rid of the denominators. So you multiply by x times x minus 6, which cancels out the entire denominator for the first one, leaving you with 1. When you multiply it to the a group, it's going to be a times x minus 6. And multiply it to the other one, and you get b times x. Now, there's some critical points that you have to find. Make your factors equal to 0. X is equal to 0. There's one critical point. x minus 6 is equal to 0, x is equal to 6. Because now we're going to use those to solve for a and b. First, what are we going to get when x is equal to 0? If I plug in 0, you get a times negative 6 plus 0. So then that means a is negative 1/6. And now plug in 6. If I plug in 6, I get 1 is equal to 0 plus 6b, b6, yeah. So that means b is 1/6. I don't think we've earned a point yet, but we're about to earn 2 points. Finishing that integral, exactly. That integral where we had a over x and b over x minus 6, that integral now becomes, I'm going to write it as negative 1/6 times 1 over x plus 1 over 6 times 1 over x minus 6. That gets you 2 points. The decomposition of the integral. And then you get 2 more points by finishing the problem, getting the antiderivatives. You get negative 1 over 6 ln of x plus 1 over 6 ln of x minus 6 plus equal. There's another 2 points. Okay. Any questions? Okay. I'm gonna go to another group for this one. Number 6. Which group? I think I'm gonna go to backup over there. Yeah, go ahead. Number 6. Sol. Join me with number 6. If you can't see, you can join the meet. Just lower the volume. Oh, good. Okay, let's get a little stretch going for the serious question, because you know what? We actually did pretty well as a class on this one. Okay. While you open up your question, the Maclaurin series for f is given. We have summation notation. We also have the series listed out. We know it converges to f of x. R is the radius. Find the radius. Use the ratio test to find the radius. Okay. Again, if you can't see, the TV's up there, or you can join. Okay. The limit as n approaches infinity of the absolute value of what? Just give me the formula. Exactly. Now, the limit as n approaches infinity. Now, take a look at your a of n, right? It's the one where you have summation notation. Wherever you see an n, replace it for an n plus 1. So, we have negative 3 to the power of n minus 1. But in this case, it's n plus 1 minus 1. There's an x to the power of n lingering. I'm just going to put it on top. X to the n plus 1 divided by n plus 1. Okay. We're going to multiply it by the reciprocal of a of n, which means it's n divided by negative 3 to the n minus 1 times x of n. X to the power of n. Some of our classmates, maybe even you guys, we made the mistake of kind of just ignoring the 3. Look. That negative 3, the first one, is just going to be negative 3 to the power of n. The x, I'm going to break it apart. The denominator, break it apart. Negative 3 to the n, negative 3 to the negative 1, x to the n. You should always break apart your powers. What can we cancel? Okay. Technically, yeah, because we're taking the limit to infinity. So you can just, the limit of those is going to be 1. This guy. And that leaves you with x to the power of 1 divided by 3. I'm just going to make it a positive because it is the absolute value. But the power is still negative 1. And because we computed the limit, I'm going to say that it's less than 1. Well, again, people forgot about this 3. This is technically 3x. Oh, and you know what? I should still technically have the absolute value until I completely remove it. Now I'm going to remove it. So negative 1/3, 1/3. Which means the radius equals 1/3. 3 points. 1 for the setup, 1 point for computing the limit and getting down to this step correctly. And the last point is for your radius. Okay. B. We're going to earn another 3 points with B right now. Okay, you got the question in front of you. They said write the first 4 non-zero terms for the Maclaurin series for f prime, and then express it as a rational function. Well, you have f of x up on top. It was given to you. So let's just get the derivative. The derivative of x, whoa, it's 1. The next term is negative 3/2 x squared. The derivative would be negative 3x. The next one would be 9x squared. But you have to go and find the fourth term and then get the derivative because they don't give you that. So let me go up on top and get the fourth term. Well, because you're starting with n is equal to 1, the first term happens when n is equal to 1. N is equal to 2, n is equal to 3. So now plug in 4. If you plug in 4, well, what do we get out of that? Negative 3 to the power of 3. Negative 27. Negative 27 over 4 times x to the power of 4. Find its derivative. Negative 27 x to the power of 3. Write the first 4 non-zero terms, okay? And then also express it as a rational function. So basically they want me to come up with an equation for f prime. Oh, but at this point we already got 2 points. Usually when they want you to find things like this, when they want you to build an equation, that usually means there's a common ratio. Which means we're multiplying by the same thing to get the next term. That's close. Negative 3x. That's what makes it alternate. That's your common ratio. So again, because they want me to build an equation, that usually means there's a common ratio. And if you have a common ratio, you can find an equation by doing a of 1 divided by 1 minus the common ratio. And we have the first term. We listed it out. It's a 1. 1 minus the common ratio. There it is. That was another point. For a total of 6. 3 more. Part C. Write the first 4 non-zero terms for the Maclaurin series for e to the x. That one, it's either memorizing it, but if you don't know it, you technically could derive it. Because it's just a Taylor series centered at 0. If you don't know it, write it out. F of c plus f prime of c times x minus c plus f double prime of c times x minus c squared divided by 2 factorial, and so on. But again, if you know it, you know it. But if not, you're going to have to derive it. Okay. The series is 1 plus x squared over 2 factorial plus x cubed over 3 factorial. Those are the first 4 non-zero terms. Write the first 4 non-zero terms and then use it to get the third degree Taylor polynomial for g of x. G of x is e to the x, which we now have, times f of x, which was given. So in other words, you just got to take your terms, 1 plus x squared over 2 factorial plus x3 over 3 factorial, dot, 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 and multiply that times the f of x series, which is x minus 3 over 2 x squared plus 3 x cubed, dot, dot, dot. If you got this far, some students made the mistake of not foiling. They just did this. And so on. That's not how it works. You need to foil. So that's gonna be x minus 3 over 2 x squared plus 3x cubed. And after that, technically you could keep going, but they say they want the third degree, which means you want to stop at a power of 3. There's no point for me to distribute the 1 any further. But I should distribute this x. If I distribute that x, I'm going to get x squared minus 3 over 2 x cubed, and then you can stop. You don't have to distribute it to the next one, because then you're going to get a 4th degree. But, okay, last thing. This x cubed, if you take this x cubed and you distribute it, you get x 4th. So we don't need that anyways. Just basically simplify what you have. That's going to be x, this guy with this guy. That gives me negative 1/2 x squared. And then 3x cubed minus this. That's positive 3 over 2x cubed. Wait, is it? Okay. But in my solutions, I wrote 2x cubed. Either I messed up or I'm in my solutions or I messed up right now. But because the bell rang, that's for you to figure out. All right. Thank you very much. You know what? Let me make a note in the video right here.
It looks easier when you don't know what you're doing. So it's easier when you're not doing the work yourself.
Let's see. Whoa. Just for the video purposes. Or is it... Oh my God. Or is it 2x cubed? Because that's what I wrote in my solutions. One of them is wrong. Maybe both of them might be wrong. Yeah, I don't know. Figure it out, guys. I ran out of time.